the final section of 8.1. We've already been simplifying rational expressions. How do we do that? We simply factor to get multiplication, and then we cancel whatever is identical on top and bottom, right? We also yesterday did multiplying and dividing fractions. Same deal, factor and then cancel. And just remember, when you divide by a fraction, you really multiply by the reciprocal of that fraction. And today, complex rational expressions. What is complex rational expressions? They're just fractions that look complicated because you have fractions within the fractions, right? So we've already done this whole front page of notes. We already started the homework. Hopefully you guys did most of the homework. And we finally get to complex rational expressions, fractions within fractions. So you have this half sheet of paper. It's this simple. When you have a fraction divided by another fraction, that's written vertically, and it's easier if you write it horizontally. So you got the 3x over 5 divided by the 3/5. And we all know that when you divide by a fraction, you change it to multiplication and flip only the second fraction, so that becomes a 5/3. Now that first fraction stays exactly the way it is. And since now you have pure multiplication, you could just cancel things out. This 5 with that 5. Then you cancel out this 3 with that 3. Only thing left is an x up on top. And you don't really need to put a 1 underneath because anything divided by 1 is itself. So it's just x. Now if everything canceled out and you had a 1 on top, then you would have to write the 1 up on top. Okay? Anywho, it's pretty easy, right? Let's take a look at number 2. Number 2 doesn't even involve any factoring either. Number 2 is just rewriting it. Do you guys want to give it a shot, or do you guys want me to do it? Me do it? Boo. All right, well, the top one, there's nothing to factor, so you just rewrite it. Now instead of this division bar, I'm just going to write the division sign. And notice that we have a -4 and then a positive x. And usually we like having the x first and the number second. So I'm going to rewrite that numerator as a positive x with a -4. And it is over x, so it's over x. And of course the division changes to multiplication. First fraction does not change. The second fraction does get flipped. So what we have over here on the second fraction is an x up on top over x minus 4. And then you could cancel this x right here with that x right there. Then you could cancel this entire binomial with that entire binomial because they're identical. What's left? Nothing, which means that the answer is 1. Remember, when everything cancels out, like 3 over 3, 3 divided by 3, the answer is 1, not 0, right? So when everything cancels out, your answer is 1. Pretty simple, I would say. But then again, I'm the math teacher. I don't know how you guys feel about it. Number 3 is a little bit more challenging, just slightly, because you could actually factor this numerator right here. There's a difference of 2 squares. You could use square roots, or you could simply think what times what is -36, that if you combine together is the middle value, which in this case is nothing, right? So let's factor this guy. And what belongs in those parentheses? A +6 and a -6, right? Okay, and that is over 6x. So all I did was rewrite this whole entire top fraction right here, but this difference of 2 squares, I factored it. And now I have this division bar, which I'm going to write as a division sign. And you know what? As I take this fraction and write it over there, I might as well flip the fraction, right? And let's not do 2 steps in one. That might get complicated. So let's just write it over there. So we're going to have it over 12. I mean, once you get really comfortable with these, you could already change it to multiplication and flip it as you go. But I'm going to keep it division and show all my steps. Anyway, it would be nice to have the x first and the 6 second. So when you do that, when you switch the order, you got to remember that the sign in front of the x actually belongs to the x. So that's a negative x that's going to go first, and a positive 6 that's going to go second. So that's a negative x that goes first, and a positive 6 that goes second. So the first fraction, nothing changes. You have the x plus 6, x minus 6 over 6x. The division, we're going to change to multiplication. And the second fraction is going to flip. You're going to have a 12 up on top and a negative x plus 6 on the bottom. Now, what could I cancel? Somebody said 6. 6 with 12? Absolutely, right? The 12 divided by 6 is 2. 6 divided by 6 is 1. What else cancels? Could I cancel this positive 6 with that positive 6? No, because this is a binomial. You'd have to treat it, you'd have to have the exact binomial to be able to cancel them, the entire binomial, okay? So the question is this binomial one of these? What's different between this x and that x? Yeah, what's the difference between this negative 6 and that positive 6? One's positive, one's negative. So if you know that they are complete opposites of each other, then we could factor out a negative 1. That way, it'll become an x minus 6. Does that make sense? I just changed the signs by pulling out a negative 1. This is definitely a skill that you guys need to acquire. All right? So that negative x plus 6, I just rewrote it as the negative 1 factored on the outside and a binomial x minus 6 left over on the inside. And now you really do have the binomial x minus 6 and the binomial x minus 6. So now you could actually cancel those out. Cancels, cancels. And what is left? Let's rewrite our answer down here. Our answer will be, well, you guys see this green 2. I'm going to write it first up on top. Green 2. And then the x plus 6, I'm going to write that, x plus 6, over, I have a 1x. I don't have to write 1 in front of x, it's just an x. But then an x times that negative 1, that will be a negative x on the bottom. So I could put a negative x on the bottom. This is a great answer. However, a better answer would be moving that negative sign from the denominator out to the front of the fraction, or maybe even to the top of the fraction. So a better answer would be negative 2 parentheses x plus 6 over x. And that was just me taking the negative and moving it out here to the front. Okay. Even if like you had a basic fraction 3 over negative 4, you're not going to really leave it 3 over negative 4. You're probably going to rewrite it as negative 3/4, right? So anytime you have a negative in the denominator, move it up or move it out to the front of the fraction. That looks nicer. And of course, if you're taking a multiple choice test, maybe you don't see either of these answers. Maybe the test generator distributed the 2 back in. So it might be a 2x plus 12 over x. But either way, I would say this is the best answer for me. I wouldn't distribute back in. You want it in factored form just in case you have like another 2 down here, then you'd be able to cancel. I definitely cannot cancel these x's because you have a plus sign. So that's the answer to number 3 on this page of examples. Number 4, look at that one. Fun stuff. I'm sure some of us forgot the formula that'll allow us to factor this. The sum or difference of 2 cubes formula. It's actually 2 formulas in one. Do you guys remember that? Sum or difference of 2 cubes formula? It's like when we had a perfect cube term, a cubed, let's say plus b cubed, that equaled a binomial times a trinomial. Still don't remember? No? Okay, well, you should know this. And if you don't remember it, memorize it now. A cubed plus b cubed. If you have perfect cube term plus a perfect cube term, then you're going to have a binomial times a trinomial. This first binomial will be what you see here, but without the cubes. They're going to disappear. You have an a plus b, no cubes. And then the trinomial will be, bless you, a squared. Now, if you had a plus right here, this next sign is going to be a negative. Minus ab and then plus b squared. Nobody remembers this? Wow, that's sad. No, there's, whenever you have any type of perfect cube term plus another perfect cube term, you identify what a and b are. In other words, you rewrite it, but without the cubes, a plus b. And then you have a squared minus ab plus b squared. Why is this a minus? Because that's a plus. Why is this a plus? Because that's what you had at the beginning. Now let's look at the other formula, the difference of two cubes formula. Same concept, a cubed minus b cubed. That's going to be a binomial times a trinomial. But this time in the binomial, I'm going to have what? A minus b. Exactly what you have here, but without the cubes. And then in the trinomial, it's going to be the same thing, a squared. But if this was a minus, then this sign has to be a plus. That's right, plus ab, and then plus b squared. Okay, so those are the two formulas that you need to know. Sum or difference of two cubes formula. So which one are we going to be applying with this guy right here? The difference of two cubes formula, right? So I might as well write it. Where do I write it? I'm going to rewrite this guy right here as a binomial times a trinomial. Okay? So the question is, what is my binomial going to be? That's right, x minus 3. So everybody write x minus 3 is a binomial. Now, notice that you're going to have an a squared right here, a squared. But in this case, your a is x, so that'll be an x squared. I hope everybody sees that, understands that, x squared. And then, if you had a minus right here, then the next sign in here in the middle is going to be a plus. So that's going to be a plus a times b. But what is ab in this case? What is ab in this case when you multiply them together? X and 3, right? Just the x and the 3. So when you multiply x and 3, 3x, right? And last but not least, you need a plus b squared over here. So what's my b squared? 9, or 3 squared, which is 9, plus 9. So I have factored this difference of two cubes. I hope we get that. So let me go back to the formula itself. You guys understand that we're using this one down here, right? The difference of two cubes formula, yeah? And you understand the formula itself, binomial times trinomial. If you had a minus here, you have a minus there. Now, the key to be able to use this formula is to safely identify what your a value is and what your b value is. And I always say do parentheses cubed minus parentheses cubed and identify what that a value is and what that b value is. So what is your a value? It's x. What is your b value? It's 3. The negative, it's just out here part of the formula. Okay. So your a value is x, your b value is 3. When you plug in x right here, right there, and a 3 right there, and right there, this is how it ends up. Does that make sense? So let's move on to the denominator of this top fraction. What could I factor right here on the x squared minus 3x? What could I pull out? On x, thank you. What's left over on the inside? X minus 3, all right? So that is the top fraction. Now I'm going to write the bottom fraction, but I'm going to write it to the side with the division sign instead of this giant division bar, okay? So I'm going to have a division sign right here, fraction over here. Up on top, I'll have the x plus 3 to the third power. I'm not actually going to do this math. I'm just going to not expand it, but write it as a binomial times a binomial times a binomial. X plus 3 times x plus 3 times x plus 3. Okay. And then this bottom one is a quadratic trinomial that I could actually factor with an x right here and an x right there. What times what is 9? That if I combine together is 6. 3 and 3. Are you with me? So I know that I need to change this to multiplication, and I also know that I need to flip this second fraction. But before doing that, maybe it'll save us some time if we could just start canceling whatever we can on each fraction itself. Like I cannot, if I had a x plus 3 right here, I don't have an x plus 3, but if I had an x plus 3 right here, I could not cancel it with that because I would still need to flip it. But if I just focus in on this right here, I could see that there's an x minus 3 and an x minus 3. You might as well cancel that so you don't have to write down that much down here when you rewrite it. So you might as well cancel this guy with that guy. And then if you look at the other fraction that has a bunch of x plus 3's, you could cancel this x plus 3 with that one with that one, and that saves you a lot of time so that when you do change it to multiplication and when you do flip it, what's left up on top up here? 1, because we're flipping it, right? And on the bottom, x plus 3. And then over here, we have the x squared plus 3x plus 9 over that blue x. Okay? Question is, could we cancel out anything else? The answer is no, right? Even if you tried, it's a quadratic trinomial, my a value is 1. What times what is 9 that if I add together is 3? There's no combo. That's simply not factorable. So this is your answer. Whenever you do have two fractions and you're multiplying, you multiply the top with the top and the bottom with the bottom and write your answer as one single fraction. So your answer will be x squared plus 3x plus 9 over x times x plus 3. This is your answer right there. I would leave it like that, but maybe on a multiple choice test you might see an x squared plus 3x in the denominator. They might distribute that x. I will always leave it in factored form just in case you're still able to factor and maybe you get a binomial like x plus 3 up here. If you could factor it, then you could cancel. The only way you'll see that you could cancel it is if you leave it in factored form. So I would leave it like this, factored form. Anyway, those are all the skills that you need to do the entire worksheet WSP 8.1. So I hope you guys already started it yesterday. I hope you could complete it today, the remainder of this class period. So once again, we have simplified fractions by factoring and canceling. We have multiplied and divided fractions. And we've dealt with complex rational expressions, which are just fractions that have fractions in them, which is just dividing by fractions. And on all of those, we factor to be able to get multiplication, to be able to cancel. Now on Monday of next week, we're going to go over adding and subtracting fractions, which, believe it or not, is a little more challenging because you need a common denominator to be able to add or subtract fractions. But we'll get to that on Monday. If you are an overachiever, you might want to look at the lessons that are already posted for Monday and Tuesday over the weekend.